Hello dear students, today we are going to talk about the revision of the chapter Rotational Mechanics. So this chapter is very important for the ITJ and NEET exams. So this is the revision class, so we'll talk about the concepts of the rotational mechanics. So first thing I'm going to talk about the relation of the linear velocity and angular velocity. Relation of V and omega. So to understand this means the relation of V and omega, we are going to consider a rigid body. So we are going to take a rigid body. Let us assume this is a rigid body and it is rotating about the axis here by the angular velocity omega. And as we have studied already that angular velocity always used to be along the axis of rotation. So what is the direction of angular velocity here? Direction of angular velocity is along the axis of rotation. So angular velocity will be like that. And here a mass particle is there. This is the mass particle m of the body. So body is made of the infinite number of masses. So this is one of them. And this mass particle is placed at distance what? R. Because this body is rotating. So therefore here this mass particle will rotate into a circular path, something like this. If this mass particle is rotating on the circular path, then dear students over here, what we can say that? We can say the linear velocity is always what? Tangent to the circular path. So linear velocity is like that, and this r is nothing but we can say that position vector. Okay, like this. And omega, as we discussed, is along the axis of rotation vertically upward. So these are three vectors. If you look at these three vectors, what do you see that? So this omega is actually along what? It is along k cap. Why along k cap? Because axis of rotation is perpendicular to the plane of the body. You can assume this body distance over here like disc or ring or any other shape. So basically omega is perpendicular to the plane of the body. Okay. So therefore if we do omega cross r, what will come? So use the right hand rule. So put your all four fingers along the first vector, that is omega. Okay, so all three things are here vector only, omega, v and r. Okay, so how is it? Its distance like this, omega is like this, here r position vector is like this, and velocity is something like this. But this velocity is in which plane? So better if I represent like this for your understanding. This is in the xy plane. Okay, so velocity is like this. So basically the v is along y axis, this is along x axis, we can say this is along z axis. Okay, so therefore if you do omega cross r, what will come? Put your right hand four fingers along the first vector. What are you doing? The cross product. So first vector here is omega. Put your four fingers along the omega. If you do omega cross r, what will come? It will come equals to v. Right now it is coming along the y direction. Okay, so your four fingers of right hand along the z direction, then move it, curl it towards the x direction. It is coming what? Your thumb is coming along the y direction. So what we can say that omega cross r is equals to v. Okay, no? So therefore this is the relation of what? V and omega. Further what we can do is so this is the relation of the angular velocity and linear velocity. In this chapter we are going to talk about the relations of the linear motion and angular motion. So if we make the relation of the linear motion and the angular motion or rotational motion, then therefore what relations we have. So here we are going to talk about relations of linear and angular motion. Angular or rotational motion. Okay, so these means what are the relations? So first thing we are going to talk about here is linear velocity, angular velocity we just discussed, but before that some basic things. In the linear motion we write, that is the displacement by what? S. Displacement we write S. But in the angular, the same thing we write what? The same thing is corresponding to the angular displacement. What is angular displacement? This we write by theta. Second thing that we talk about here is velocity. Okay, so linear velocity, what we write? We write V. Angular velocity, what we write is over here? Angular velocity we write omega. Okay, and what is relation between them? We just discussed already. Okay, V equals to omega cross R. Right now. And what was the relation here in the linear displacement and angular displacement? Linear displacement distance is equals to R into theta. Okay, no? Actually linear displacement is nothing but distance arc length. You might have studied already. Arc length we write equal to radius into what? Angle. So S equal to R theta. Okay, so first relation is S equal to R theta. Second is V equal to omega cross R. Third relation distance we are going to talk about over here is, that is linear acceleration. Linear acceleration, what we write? Linear acceleration or acceleration we write T. Okay, and angular acceleration we write by alpha. We write distance by alpha. And what is relation? Actually from the V equal to omega cross R, what we can write? If I differentiate both side distance by considering position vector as constant for a particle, so what I can write? I can write dV by dt. See, from the previous relation V equal to omega cross R, I am writing this. So I can write d omega by dt cross R. Right now this dV by dt we write acceleration. D omega by dt distance we can write alpha cross R. Okay, so we got another relation A equals to alpha cross R, right? And this relation distance we can write in the scalar form. This was the vector form, so we can write simply R alpha. This is the scalar form. Okay, so this is the linear acceleration and angular acceleration relation. Right now, next thing that we are going to talk about is next ahead is the some more common things, like how we define force and torque into the linear motion and angular motion. So this means the force in the linear motion we write force, and force F, this force is corresponding to the angular, that is the torque into the angular motion. So force is corresponding to torque tau. Okay, it is not equal, it is corresponding. Okay, so therefore how we define torque distance? Torque we define equals to R cross F. This is the vector form. or we write F into R into sine theta, because cross product we can write like that. Okay, no? So this is the one of the form. So here dear students, force we write equal to what? Mass into acceleration. So similar to force in the rotation we write torque. So torque, how we can define? This is the second definition of the torque. We can write mass is similar to the moment of inertia. Okay, mass is similar to what in rotation? Moment of inertia. A is similar to alpha, so we can write tau equal to y alpha. This is the second relation. Similarly, dear students, we can write relation of the more things. Next one I'm going to take, that is the impulse. Impulse I, dear students, or J, we write impulse I or by J. So this impulse we write equals to what? Impulse I or J we write F into delta t, or this we say that change into the angular moment, change into momentum. So this is for linear, so we'll say that change in the momentum of the body, not angular momentum. Okay, but when we talk about the impulse of what? When we talk about impulse into the angular motion, then this same impulse we write, dear students, I equals to, tell me, force is similar to what? Torque. Okay, torque into delta t. Delta t will be the same, and this linear momentum will be the angular momentum changing to the angular momentum. Okay. Now next thing we are going to talk about is work done. Okay, so how we define work into the linear motion? So before work, let us talk about the momentum only. Okay, so momentum in the linear motion, distance we write, okay, m delta v, or m into, if mass is constant, then m into v2 minus v1. If mass is variable distance, then therefore what will take that? m2 v2 minus, if mass is changing, then we'll take like that. Okay, this is the change in of the momentum. So in the angular motion, what is the change of the momentum? Yes, change of momentum ds means we write change of angular momentum, because in the angular motion it is angular momentum. So at the place of mass, what will write? I, and at the place of delta v, what will write? Delta omega. So this is change of the angular momentum. Okay, and only angular momentum, how we write? Only angular momentum we write I into omega. Okay. In the linear motion, we had talked about, remember, in our regular classes, that is the conservation of what? Linear momentum. What is the conservation of linear momentum? Conservation of linear momentum. Conservation of linear momentum was ds means, remember what we had said, if net external force is 0 acting on the body, then therefore we say that initial momentum is equal to final momentum of a body, or we can say at any time momentum of a body remains constant. Okay, or we had said p1 equals to p2. So momentum at one time p1 equal to p2. So momentum at the one time p1, what we can write? This we can write m1 v1 equal to m2 v2, or we can say mv is constant, right? No, here means we talk about the conservation of what? The angular momentum. Okay, so conservation of angular momentum, am means angular momentum. Okay, so here what will say that, if here condition was if net external force is 0, here what will say that if net external torque acting on the body is 0, then therefore angular momentum remains conserved. Angular momentum remains conserved means what? L will be constant at any time. L will be constant means ds means we can say that here L1 is equals to L2, isn't it? And angular momentum, how we write? Angular momentum we write is equals to that I1 omega 1 equal to I2 omega 2. Okay, so this is the conservation of what? Angular momentum. How the question comes on that? This means the question comes on that if we change suppose the shape of the body, then angular again moment of inertia will change. Okay, suppose the question comes from something like this. If we reduce the shape of the earth to its half, then what will be the time period of its rotation? You already know that the time period of rotation of earth around its own axis is the 24 hours, right? So actually omega 1 you can write 2 pi by t1, and that is initial time, okay, is the 24 hours. But when earth shape reduced to half means now radius reduces to half, so moment of inertia will also reduces to half. You already know that moment of inertia earth is spherical, so moment of inertia of sphere ds is 2 by 5 mr square, right? No, so therefore you can find the omega 2 or time period of the body when, okay, the I reduces to half. Reduces to half means in the second time you will take the radius to the half, and you can calculate the time period when the earth, that is radius, reduces to half. What will be the time period of the rotation on its own axis? So this is how the question used to come. We will solve the question in detail ahead. So first let us finish the recap of the chapter. Okay, so next thing that we are going to talk about here is in the relation of the linear and angular momentum. Linear and angular motions are the next one. Eighth point is the work done. So work done, how we define? For linear motion, work done we define equal to force F dot S, right? No, so same thing, work done we define into angular motion. F ds means I had told you already is the similar to the torque tau, and linear displacement is similar to the angular displacement, so tau dot theta. This we write Fs cos theta as well, and this we can write tau theta cos theta as well. Okay, so now we define work done like this, and similarly we can talk about the power as well. If we talk about the power, then therefore here ninth one, power, how we define this means power P in the linear motion we define P equals to what? P is equals to the rate of work done. Rate of work done means W by T. This we write ds means what? This we write, okay, F dot S by T. So same thing, power what we can write into the rotation? Yes, in the rotation ds means power we can write equals to the force is similar to the torque, F dot theta by T, like that. Okay, here power we write equals to power, what we write? This S by T, what we can write? We can write V. So power equals to F dot V, we write into the linear motion, right? No, and in angular motion same thing, what we can write here? Okay, tau, this theta by T we can write omega, right? No, so tau dot omega, right? So these are some basic relations